Welcome back to the Engineer Squad channel. In this video, we will practice solving a problem related to projectile motion. Given the equation of the projectile's trajectory, where r is in meters and t is in seconds, determine the maximum horizontal distance and the maximum height of that projectile. From the trajectory equation, we see the term with the I vector, which represents motion along the x-axis, or rx, with rx equals 10ti. Meanwhile, the term with the j vector represents motion along the y-axis, which is 16t minus 2t squared. Rx is linear motion, while Ry is uniformly accelerated motion because Ry has form of a quadratic equation. Let's draw an illustration of this problem. The projectile has a motion r, where r consists of motion along the y-axis and motion along the x-axis, or rx. The projectile will follow the blue trajectory and eventually return to the ground, where it will come to rest. The distance from the initial position to the final position is the maximum of Rx. The maximum height is reached at the peak of the parabola. The maximum Rx is achieved when the y value is 0, or when the projectile has returned to the ground. The maximum Ry is reached at the peak of the parabola, where the object has a horizontal velocity vx and a vertical velocity vy of 0, as the object in the peak is no longer moving upward and will begin to move downward. Next, we will find the maximum value of Rx, which is achieved when y equals 0. We substitute the equation for motion along the y-axis. This can be factored into 2t multiplied by, in parentheses, 8 minus t. For the first factor, 2t equals 0, so t equals 0. For the second factor, 8 minus t equals 0. We get t equals 8 seconds. We denote it as t1, represents the object's condition at the start of its motion, and t2 represents the object's position at the end of motion, or when it has returned to the ground. To find the maximum Rx, we substitute t2. We find that the maximum horizontal distance is 80 meters. Next, we will determine the maximum Ry. The maximum height is achieved when Vy, or the vertical velocity, equals 0. Before we continue this discussion, we would ask you to like this video and subscribe to the Engineer Squad channel. Thanks a lot. Your support means so much to us and helps keeping this channel. Now, let's get back to solve this problem. We remember that velocity is the derivative of distance with respect to time. Let's take our y and differentiate it with respect to t. Differentiating 16t with respect to t gives 16. For the second term, the coefficient remains 2, and the exponent on t moves to the front, as shown in red. The exponent of t decreases from 2 to 1, becoming 1. The equation becomes 16 minus 4t equals 0. We find t equals 4 seconds. This value represents the time at which the vertical position is at its maximum. Next, we will substitute this t value into the formula of our y. It becomes 16 times 4 minus 2 times 4 squared. Result in 32 meters. Now, let's return to this trajectory graph. We have successfully answered the question, and we get that our x maximum is 80 meters, and our y maximum is 32 meters. Thank you for following this problem discussion. Here is important notes related to uniformly accelerated motion and simple derivative rule. We hope this video is useful for our understanding. See you in another physics problem discussion.